Hey, so if you've written even just one line of Java code, you've definitely used a string. I mean, it's just text, right? Seems pretty simple. But that simplicity is, well, it's a bit of an illusion. Today, we're going to pull back that curtain on Java strings and show you why really getting them is a game changer for writing better, smarter code.
So let's start with a little puzzle, one that every single Java developer bumps into. You know how when you declare a number, you use a lowercase int? But for text, it's always a big uppercase string. Now that's not just some random style choice. Oh no, it's a huge clue about what a string really is. So keep that question in your head, because we're about to crack this case wide open.
Here's our game plan. We'll start with the basics, then get to the big reveal about what a string actually is. We'll look at the two different ways you can create them, see where they live in your computer's memory, and finally, check out all the cool things we can do with them.
All right, let's kick things off on familiar ground. We're going to look at the way pretty much everyone first meets and uses strings in their code.
Okay, so on the left, you've got your classic primitive type. Int. Simple, straightforward, lowercase I. But then look at the right. There's the string. Notice those two big clues we talked about, the capital S and the fact that the word Java is wrapped up in double quotes. This syntax is telling us a story, and it's our first big hint that strings are playing a totally different game.
So at its very core, what is a string? Well, it's just a sequence of characters. You know, a name, a message, a password, anything like that. You just wrap it in double quotes, and boom, Java knows it's a string. But that's just the surface. What's happening underneath that simple definition is way more interesting.
And now it's time for the big reveal. Let's finally solve the mystery of that capital S and uncover the true identity of the string in Java.
Here it is. This is the whole key. A string is not a primitive data type, like int or char or boolean. Nope, it is a full-blown class. And if you can get your head around this one single fact, everything else about strings will just click into place.
So what in the world is a class? Honestly, just think of it like a blueprint. A blueprint isn't the house itself, right? It's the detailed plan you use to build lots of houses. In Java, a class is the blueprint for creating objects, and it bundles two really important things together. Data, like the actual letters in the text, and methods, which are the actions you can perform on that text. This means a string isn't just a simple value. It's a smart object with its own set of built-in tools.
Okay, so now we know a string is a class. The next logical question is, how do we build an object from this blueprint? Well, it turns out Java gives us two totally different ways to do it.
On the left is the simple shortcut we all know and love, called a string literal. But check out the right side. That's the more official, object-oriented way. See that new keyword? That is the standard, by-the-book way you create an object from any class in Java. So the one on the right is what we should expect. The one on the left, well, that's a special privilege that Java gives only to strings.
And this really highlights a fundamental rule in Java. That new keyword is basically an instruction. It tells the Java virtual machine, hey, go find the class blueprint and build me a brand new object in memory. So now let's talk about what in-memory actually means.
When you use that new keyword and create an object, where does it, go? Inside your computer? To get this, we need to take a quick peek at the two main spots where Java stores information, the stack and the heap. This concept is absolutely crucial. On the left, you've got the stack. Think of it like the contact list in your phone. It's super fast, really organized, and it just stores simple stuff like numbers and, most importantly, the names of our objects. Then, on the right, you have the heap. This is a much bigger, more wide-open space where the actual complex objects themselves live. So the stack has the contact name, but the heap is where the actual person lives. One is a pointer, the other is the real deal.
So let's walk through what happens when we make a string this way. First, Java sees string name. It immediately creates a little placeholder called name in that fast stack memory. Think of it as an empty box. Second, it sees new string, and it goes to the big heap memory and builds the actual string object, giving it a unique address. Finally, that equal sign connects them. It takes the memory address from the heap and sticks it into the name variable on the stack. So name isn't holding the text Naveen, it's holding the location of the text.
All right, now for the fun part. We've done the heavy lifting, we understand string is a class and an object. So what's the payoff? What can this fancy object do that a boring old primitive type can?
Because a string is an object built from that class blueprint, it comes with a whole toolbox of built-in functions called methods.
And it also gets a really cool superpower that's pretty much unique among objects. It can use the plus operator, the plus sign, to join text together. We call that concatenation. Let's see it in action.
So check this out. We can use the simple plus sign to stitch strings together. That's concatenation. But because it's an object, we can also use its built-in tools. For instance, we can call .charat of 0 on our name object and basically ask it, hey, what's the character at your very first position? We can also use other methods like .concat to do the same thing as the plus sign. These are awesome abilities that a simple int just doesn't have.
And this brings us right back to where we started. Why can we just write string name equals Naveen without that whole new keyword business? Well, the answer is just convenience. The people who made Java knew that we use strings all the time, so they built this beautiful little shortcut right into the language to make our lives easier. Behind the scenes, Java is still creating an object for you in the heap, but it just handles all the dirty work for you.
Okay, let's do a quick recap. The absolute #1 thing to remember: string is a class, not a primitive. That's why it's got a capital S. You can make string objects with the easy literal shortcut or the official new keyword. And don't forget the memory model. The variable on the stack just points to the real object on the heap. And finally, being a class is what gives strings all their power, all those super useful built-in methods.
So we've established that strings are these powerful objects, but that brings up a really interesting question. If they're objects, can we, change them after we've created them? Like, could we take our Naveen string and just change the first letter to a K to make it Kaveen? Well, the answer to that question reveals another massive core feature of Java strings, something called immutability. And that, my friends, is a story for our next explainer.